Alright, so in this example we're being asked to solve by finding the roots. So they want us to solve the following polynomial, okay? But before we do that, we need to bring this down to a quadratic, okay? Because we can't factor this. So we want to bring it down to a quadratic so then that we can use the quadratic formula, factor it in order to find the roots, okay? So what we're going to have to do here is use the rational root theorem. And that is when you have P over Q. Now P is talking about your constant and Q is talking about your leading coefficient. And all we're going to do is write out the factors of both our constant and our leading coefficient. So for example, if I go to my constant, I'm going to write out the factors. So it's negative 15. I'm going to have plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Okay? If I go to my leading coefficient, which is going to be 1, well, those factors are going to be plus or minus 1. And all you do at this point is do out the operation. So we're going to get plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Again, all you're doing is division here, okay? So we know that anything divided by 1 or plus or minus 1 is just going to be itself, right? So these are all the possible rational roots. Remember, this is only for rational roots. It doesn't give you possible irrational roots or imaginary roots, okay? So let's go ahead and set this up. We're going to have to use synthetic division here. So in order to do that, we go to our function, okay? And we're just going to go ahead and write out the coefficients. Now, it's important to see if you're skipping any terms. So notice here how I have x to the fourth, x to the third, x to the second, x, and then our constant. We're going right in order. We're not skipping any terms. So we don't have to add any zeros in for the coefficients, okay? So when you set up your synthetic division, again, you're just writing out the coefficients. You're going to write 1, negative 2, negative 14, negative 2, and negative 15. And at this point, this is essentially kind of guess and check, all right? So we're just going to pick one of these possible rational roots. I'm just going to start with 1. The goal is to get a remainder of 0. If you get a remainder of 0 at the end, then you know it's going to be a root of the function. So starting with 1, right, let's do synthetic division. We bring down the 1. Here we get 1, right? 1 times 1 is 1. And then here we get negative 1. Again, negative 2 plus 1, negative 1. Again, multiplying, we get negative 1, so negative 15. Here we get negative 15. This is going to give us negative 17. So we can see here that our remainder is not going to be 0. Okay, so we know that 1 is not a rational root of this function. Okay, so we need to try again. So let's erase this. And let's try another possible rational root. Let's try 5. Okay, so bring down the 1. 5 times 1 is 5. This is going to give us 3. Here we get 15. 1. Okay, 3. And then 15. So look here, our remainder is 0, meaning that yes, 5 is going to be a rational root. It's going to be a root of this function. Okay? And now that you have a remainder of 0, you don't even have to set it up again. You can just continue on. Alright, so I'm going to set up another synthetic division bar. And I'm going to pick another possible rational root. I'll pick negative 3 here. And again, the goal is to get a remainder of 0. So bring down the 1. Here we get negative 3. This gives us 0. Right, 0. Bring down the 1. Negative 3. So again, we can see here that our remainder is also 0. That's what we want. Now remember, when you use synthetic division, each time you do it, you naturally bring it down a degree. So this is now x squared, x, and our constant, and yes, negative 3 is going to be a 0 of this function. Okay? So now we have it down to a quadratic. Now we have options to find the remaining 2 zeros, right? We can use quadratic formula, factor and complete the square, right? So writing this out, we're going to get x squared. This is just 0, so we don't have to write it, and then plus 1. So looking at this, this can't be factored. Okay, this cannot be factored. So what we're going to do here is just use the quadratic formula. All right, so let's go ahead and record our known zeros. They're going to be the following. We get 5 and negative 3. Okay, so let's write out the quadratic formula in case you forgot. It's going to be negative b plus or minus the square root of. Here we get b squared minus 4 times a times c all over 2 times a. Okay, so again, this is referring to a quadratic in standard form, which is ax squared plus bx plus c. All right, so all we're going to do is fill in our values. So my b here, well, it's just 0. So all I have to do is put 0 here. So I have 0 plus or minus the square root of, again, b is going to be 0, so just put 0, minus 4 times a, which is going to be 1, times c, which is going to also be 1, and then 2 times a, so that's just going to be 2, right? 2 times 1. So doing this out, we're going to get plus or minus the square root of, and here we're going to get negative 4, right? All over 2. So we can see here that this is going to be imaginary. We have a negative underneath the square root. We're going to pull that out, and we're going to call it I. So we get plus or minus I square root of 4 all over 2. We know that the square root of 4 is 2. So now we get plus or minus 2i all over 2. Okay, and we can write out our final zeros here. Let's erase this. So doing this operation out, let's just do the positive one first. 2i divided by 2 is just I. And negative 2i divided by 2 is going to be negative I. So we have 4 total zeros here, right? 2 of them are going to be real, the other 2 are imaginary. So writing them out, we get x equals 5, x equals negative 3, x equals I, and x equals negative I. Okay, here are the zeros or the roots of the function. Okay, and that is it.